Okay, so I think I don't need a microphone. Can you hear me well? Yeah, okay. Well, thank you for coming for my talk. My name is Jan Rellermeyer. I'm with IBM Research in Austin, Texas, and also an adjunct professor at the University of Texas. And today I will talk about lean and easy IoT application with OSGi and Eclipse Concierge. So, greetings from our lawyers, indeed. How many in here of you are aware of IoT and OSGi? Yeah? So a few of you. For me, OSGi is really the natural fit for IoT. And that comes from the fact that actually OSGi was invented for things that were IoT before you used to call them that way, right? So in the old days, we had these set-top boxes on top of televisions, and they were supposed to be the gateways for what people thought were smart homes back then, right? And these devices had a distinct problem. They were running very long-running software, right? They were running basically all of the time. And you needed to make software updates to them, which is a very common problem of software lifecycle management. So what was the state of the art back then in the days? Well, it's basically the antithesis of agile software development, right? It's the reboot button. Every time you change something in your system, you have to do a full system reboot. And that's, of course, very unpleasant. So the entire idea of OSGi initially was, well, you might have different applications running on your set-top box. So most of them are actually completely disjoint, right? If you modularize them properly, and model the dependencies between your application components properly, you can restrict the scope of a reboot to those components who are actually affected, and the rest will just be fine and up and running, right? So that was the original motivation for OSGi. And I think these things are still true in today's world with IoT, maybe even more so because, you know, the update cycles back in the day was maybe a quarterly update that was coming from your provider. These days, applications have to be much more agile, and time to market is much shorter. So I would really say that the problem of software lifecycle management has become more severe and not less, right? So how does OSGi manage that? Well, the unit of modularity in OSGi is called a bundle, right? A bundle is really not something new in the sense that it piggybacks on the jar file format. So no special tools required other than enhancing your manifest and basically making your dependencies explicit, right? So in some sense, a bundle is just a jar file with additional metadata, right? In order to run these bundles, you need a runtime environment that sits on top of your Java virtual machine, and this is called a framework. You can debate whether or not that's the best way to call it, but that's the name that the original developers choose for it, right? So the framework is an actively running component which allows you to manage and interact with your modules, with your bundles, the way you want and control their lifecycle in an explicit way. The next thing that you have is that these bundles implement isolation, right? Isolation in the sense that every bundle by itself is just a unit of isolation. You cannot share things arbitrarily, which in a Java virtual machine normally you can, right? When you load a jar file into your class path, it's becoming globally available, right? So you limit the scope of sharing to the dependencies that you have explicitly declared. And that way you can minimize the effect of lifecycle management event to those modules that are directly affected. Now, the final component in an OSGi framework on the module layer is, because things can be dynamic and change over time, you should actually listen to these change events, right? An OSGi framework gives you an infrastructure to subscribe for events, and your application has a chance to react to them accordingly. All right. This is my picture of a running OSGi framework that I used for many, many years to explain how sharing works in such an environment, right? The unit of sharing in OSGi is by default a package, right? So your modules have multiple packages. Some of them might be private, which means they are application dependent and not intended to be API. And all of them will be hidden from the rest of the world, right? Unless you explicitly declare them as being exported, they will be completely in isolation, which is actually good, right? At the point where you export a package, this package is now available to the rest of your system, and other bundles can import them. which this bundle here does for package 1, right? And they themselves can indeed also export packages. Now, whenever you have such a relationship between an export and an import package, we call this a wire in our system, right? So at runtime, you will have a provider. Yes?
Sorry to interrupt. Would you mind putting this on?
No.
So we can hear you on the recording?
Sure.
Thank you. Just clip that in your pocket.
I will.
Thank you.
Okay. So this wire means that there is an export and import relationship in your system. And these wires is what we can track, right, in order to minimize the impact. In any realistic system, we will actually have multiple versions of bundles running. Let this be an application server, right? It's very often the case that you have the same exact package conceptually, but different versions of it, because some components in your system might have to bind to different revisions of the same software. Logging frameworks are notorious for that, right? So another thing that OSGi has introduced is explicit versioning for packages, right? Every export and import should hopefully have a version attached to it. Imports usually have ranges, so you can say, this bundle here can tolerate an import of, let's say, log4j in the range 2.0 until 3.0 exclusively, right? And that way, you have the freedom in your system to have multiple versions, which honestly in Java, otherwise you cannot, because you get name collisions. But because we have isolation in our system, and every bundle is loaded through a separate class loader, this OSGi framework can run multiple systems, multiple versions of a bundle at the same time simultaneously. Okay, so much for the module layer. Now, if the module layer was all that we really had, it wouldn't still be a very flexible system, right? Because at the end of the day, if you have a piece of software that depends on other components, just componentizing it doesn't make it more flexible. At a certain point in time, you need all of them to be present in your system. Otherwise, your application will not load, right? Because at the end of the day, Java is a language that does late binding. But at the point where you need to bind, it basically becomes a linker level dependency, right? It's the equivalent of doing DL open in good old C programs, right? At the point in time where you do it and you don't have the dependency available, your software will fail, right? So modules alone is a good way of managing your lifecycle, but it still creates tight coupling in your system and ultimately limits the modularity. This is why OSGi has introduced another component that is called the service layer. So you have a central service registry in your system, and every bundle can also register services or ask to consume services, okay? Now, the entire idea behind a service is, in the end, very simple. If you have your implementation and you abstract away from it through an interface, the linker level dependency will be solely on the interface and not on the implementation, right? And that is ultimately what causes loose coupling in your system. Because at the point where previously you would, do late loading and fall into a hole because the component wasn't there, in this system, you might only need the interface, and that can be part of your application. And then you can dynamically look for a provider in your system, right? You don't need to be coupled to this. So services, in the end, cause loose coupling in your system. And OSGi, even before microservices were a thing, was doing that on a single Java virtual machine and in the least obstructive way that you can implement it. Because in the end, you can ask for an OSGi service pretty much by its name or by its class. But at the point in time where you have asked that to the service registry, you will get a Java object in return. So there is no full proxification going on like in JEE, right? There is no overhead for consuming a service after you have retrieved it from the service registry. And that was indeed motivated by the original design domain, which was embedded systems where you cannot afford full proxification due to the overhead. Okay, now the same things that I said for the module layer are indeed true for the service layer in that you need to listen to events, right? And you can listen to events. So if your application, for instance, supports logging as an optional part, right? In the sense that it can do fine without a logger installed, it will just not log. And at the point where you really need log output, you just dynamically install a log component, right? What you would do is just listen for this service becomes available event, and then you can retrieve the log service and start producing log output dynamically, right? that indeed is a lot more loosely coupled and a lot more flexible. Another thing that is important to point out, services help you with M-to-N or N-to-M dependencies, right? There can be multiple service providers in the system, and you just pick the best one based on a criteria. And OSGi supports full LDAP string filters in order to match whatever means the best available provider of a service, right? And at the same time, indeed, you can have multiple consumers of a service in your system. So, this ultimately is what makes building OSGi applications for IoT really pleasant, right? There is this whiteboard pattern in the OSGi universe, which is often used in order to decouple event sources and event listeners, right? And in order to just fully appreciate that, think of a traditional public subscribe system. Normally what you do is if you're interested in consuming an event, right, you have to explicitly subscribe to a provider, right? So to a publisher, right? So that means in the event that there is no publisher available, you have to special case all this code, right? And wait for a publisher to become available and so on. And it's also not trivial to consume from multiple publishers, right? Now, the way how you solve that is just creating this middle entity here, which conveniently is just the OSGi service registry, right? So in this universe, the event listener will register itself and thereby mark its availability. And everybody who wants to publish something will just try to look up all the listeners that are available and send the events to the listeners, right? And thereby you have a nice system in which you can model this end-to-end relationship very conveniently. Now, in the end, this is not rocket science, because if you think a little bit from a high-level perspective, this is exactly what a message broker would also do for you in the large scale, right? A message broker is a mailbox component in the middle where basically publishers and subscribers can individually register themselves, and then the broker interconnects these, right? But here you can do this within a single Java virtual machine and basically exploit this functionality at the very lowest level to write more flexible applications. So we have this Eclipse Concierge project that we have been working on for a little more than 2 years, I think now, very actively. And initially we had this idea of, you know, OSGi is really a natural fit for IoT, and it's coming from this domain. But many implementations of OSGi have significantly grown over time, simply because OSGi became tremendously popular in, you know, large-scale applications, such as application servers, or even your Eclipse IDE is a pretty big application by itself with hundreds or even more bundles, right? So we wanted to see if we could reduce the footprint of OSGi up to a level where it's really nice and pleasant to use this on an embedded device. And I initially wrote an R3 implementation back in the days that was still around, but we thought it was time to bring it up to speed with the latest standards and pretty much allow you to use the same runtime environment that you would also use maybe server-side or in large applications. So our goals were pretty clear, right? We want to reach OSGi Core R5 compatibility, which was pretty much the latest at that time, right? At the same time, we want to keep the footprint small enough to work well on embedded devices, and also remain readable. By that, we mean the source code, right? OSGi is not the easiest beast to understand, and the old implementation was actually used by quite a lot of people in order to understand how a framework would work internally, because it was just a handful of classes, and you can actually read it, right? At the same time, the state of the art for a very long time was that Java on embedded was basically behind Java on larger systems by a couple of revisions, right? So the best that you could get pretty much right before we started was a Java 1.4 compatible virtual machine. Simply because, you know, the CDC foundation profiles and so on, they were never updated after Java moved on to 5 and 6 and 7, right? So we worked on this for a while, and I think we made good progress with all the goals, right? In the end, we settled for Java 5 because the compact profile was coming to our rescue. So, you know, we thought compact is something that you would actually run on, let's say, a Raspberry Pi or so. Not necessarily a need anymore to remain compatible with 1.4. But if you look at it, it still has only 9 classes, 45 inner classes or so. That's the nature of Java, right? In terms of size, we are at 250 kilobytes without debug symbols. And if you want debug symbols, 330 kilobytes. That's pretty small by the standard of an OSGI framework. And pretty much last year, we achieved the goal of being R5, fully R5 core compatible. So how can you build applications with the Concierge framework? Well, let me just switch my screen real quick and show you a little bit how that works in practice. Let me see. Can you see that? Yeah. So this is my Raspberry Pi, the device that is dangling here from the lectern, right? And if you just install Concierge, the latest snapshot, you can do already a couple of things with it. So we provide a couple of applications out of the box, and maybe the easiest one is just a shell application, right? So just go into the Concierge folder that you will get, use your Java virtual machine. Oops. Right? And then start it. The information of which bundles you want to start is stored in an Xarg file. That's kind of borrowed from Knopflerfish, in case you have ever worked with it. That's just a small text file that gives you imperative instructions what to do on system startup. And you know, after 0.008 seconds, which is pretty good on an embedded device, you get a shell, and you can already introspect what's going on into your system. And so on, right? So you can see the bundles and services. And, you know. Okay, let's close this down. So I said pretty much all that you have to do is write a little Xarg files. And we go a little bit beyond what you can do with Knopflerfish, because we use this in an environment where changes are happening frequently. So one problem that you might already know from your experience is, you know, you build all these integration builds and snapshots build and whatever, right? Here we support variables and wildcards in order to factor these things out and basically reuse your startup script, right? So what you see here is we have prefixed some of our bundles that we want to install and start with this repo command, and then we can quickly switch from an environment where we want to load them right from the internet to an environment where we load them from a local repository, right? Those are kind of productivity things that make working with, especially on an embedded device, a lot more pleasant, right? The other thing is we support wildcards, so you don't have to give the exact same build number, right? Which changes every time that you maybe run your build. Just use a wildcard and it will pick up the latest version because it sorts by lexical sorting. Right? So that's basically all that is involved in order to get into this technology. Just download it and write an Xarg script and start your components. Okay. Now, once you build more sophisticated things, you might want to have something better than just a command line interface. And as part of Concierge, we have implemented a REST interface for OSGI frameworks. In fact, that's even the reference implementation for the REST standard. And yes, we have finally integrated this into our build. If you download one of the latest snapshot releases, it's coming as part of it, right? So what I can do now is go back. Just if we go into the full distribution, you see that there is a bunch of scripts already provided with it, and one of them is the REST implementation. So what I can do is just start, where is it? No. Start the Concierge framework. Where am I? Oh. Framework. Jar. And then I give it a startup file, and that would be samples REST. Okay. And, you know, it takes a tiny little longer because it's starting a full web server and so on. But, you know, at this point, I basically have a REST interface to my embedded device. And now if I pull up another window, I can make REST calls to my device. For instance, introspecting, you know, all the bundles. And yes, if you saw the exception here, it's because this thing does not route through to the internet, so it cannot get the schema, right? That is a necessary evil in such an environment. Okay, so you know, this is basically another way of interacting with an OSGI framework in an IoT environment. And you know, I would think the nice thing about that is that you can seamlessly use that in, let's say, your web interface, right? So if you are building an application, you might want to abstract away from bundles and, you know, services and provide a view that is more consistent with your business logic. But in the end, in order to do so successfully, you need to have access to all the bundles and services and introspect the state, right? And this thing here makes it very easy to write your interface for your application while having access to the low-level information. All right, so let's have a quick look of, on what other people have done with our implementation, although other people mainly involves my committers in these examples. This is one thing that Jochen Hiller from Deutsche Telekom has worked on. There is this Eclipse Smart Home project. Conveniently, the chair is even here in the room, right? And he took the exercise and took basically Smart Home, adapted it to run on Concierge. And you see that he made a couple of changes. Not all of them are directly related to Concierge. It's more of a concerted effort to reduce the footprint, right? But if you look at the different numbers between OpenHAB 2, which is the full-fledged implementation of Smart Home, and his distribution that runs on Concierge, you see that you know, there are a couple of interesting differences, right? The distribution size has definitely gone down quite a bit. He also got rid of some of the frameworks that might not necessarily be the best idea to run on a small and embedded device. But in the end, he brought it down to a point where it runs on Compact 2 or Compact 3, which reduces the footprint of the Java runtime. And in the end, you know, memory footprint has gone down, and also startup time has gone down, right? Startup time might seem trivial, but at least at the point where you're debugging something and you're doing it 20 times per hour, that can really make a difference, right? Another thing, another committer of the project, Tim Verbelen, who is very active also working on the Concierge framework, he works in a research lab in Belgium called iMinds, and they are all in on IoT and, you know, machine learning and so on. So what you see here is what they call their Internet of Things lab. This is an application, right? You see a view that is application specific, but it runs on the Concierge framework, and it's using all the low-level control mechanism and control points into the framework. And basically what they have is a system where you can compose your IoT application, provide reusable units of IoT logic, and then do the orchestration. And because they combine it with the idea of OSGi remote services, they can basically seamlessly distribute components and change the deployment if you need to, right? So let me see if this works. What you see here is one of their setups. That is actually an orange detection system, very, very sophisticated, right? And it consists of a couple of components here, right? What we have here is an NVIDIA Jetson. That's a small embedded platform that has very good GPU power. And that's what you really want for machine learning algorithm, because it's a lot of floating point number crunching, right? Then we have a Raspberry Pi right there. We have a robotic arm. We have this camera. So the setup is that you will place a fruit here in front of this white screen. The camera will detect the picture. The Jetson device will analyze the picture with the machine learning kernel and then decide whether or not this is an orange. And if it's not an orange, the robotic arm will just swipe it away, right? Now, the nice thing and the big enabler here is he runs Concierge both on the Jetson and the Raspberry Pi. And let's say if you did not have access to a Jetson platform, you could just move this component out in the cloud, right? And use OSGi remote services. And the application would actually require absolutely zero modifications to the source code. So by modularizing and componentizing your system, you gain the freedom of picking a deployment that makes sense based on your system's requirement. Right? So just for fun, I can show you how this works. Oh yeah, and there's this light bulb. You see it's red when it doesn't detect something, and then it will turn into either yellow or orange, which you cannot really tell in the video, but oh. Let's play this video. So first object for detection, it's a lemon. No good, right? Second test object, orange, accepted, okay? So, you know, you could see how these applications can compose and become larger and eventually build quite sophisticated IoT application out of individual components. But yes, the ability to pick your deployment and move components around is actually a very strong enabler in this case. Another use case that Tim worked on, he's actively in contributing to the OSGi Alliance on embedded systems. And they have this OSGi en route, or en route, if you pronounce it French, framework, which normally requires an OSGi R6 implementation. But Tim basically worked on Concierge and brought it to R6 kind of compliance in a snapshot branch. So he actually uses en route also with Concierge. And it's very easy to integrate it, right? En route is all about BND tools, using BND tools for build and deployment. And you can just specify Concierge as your framework, and it will just work out of the box. No need to change anything. Okay, so you've seen a couple of use cases, but you know, our claim to fame is trying to be lean and performing well on small devices, which I still have to prove to you, right? So in all of my talks on Concierge, I have this section where I just compare the performance of the different frameworks. And you know, to have some realistic platforms that represent embedded systems, I traditionally have my old Raspberry Pi B and a BeagleBone platform, right? They are a little bit different devices, different ARM CPUs. Also, the Raspberry Pi has more memory, but then it has a larger operating system. So in practice, the difference is not even that much. The nice thing about the BeagleBone is that you can actually run a 1.8 compact profile on it. It's relatively easy to build one. And there is a Java SE embedded version 1.7 that you can also run on it. Whereas the Pi basically comes pre-packaged with a full JVM. So let's compare the state of the art in OSGi right now. So the first candidate is Eclipse Equinox, and that I think is the Neon R2 release that was released in last November or so. Keep in mind that this is an R6 framework, so it has more functionality than the other frameworks. All the others are R5 frameworks, at least in the master branch, right? The other candidate is Apache Felix, released this year, just a couple of weeks old. Knopflerfish, which is still the R5 implementation, 7.2.0, released last fall. And then Concierge, that's the bleeding edge snapshot that I built last week. Right? You already see that the footprint of the different OSGi implementations is quite different, ranging from over a megabyte to 248 kilobyte. Part of that is, you know, how much additional functionality you put into the framework. Concierge tends to be very much on the lean end. The only component that we add as an extra is logging, and that is for a good reason. Because ultimately, one of the negative experiences that people have with OSGi is that after componentizing and after you introduce isolation into your system, some pieces of software will just start to fail, right? They will not run anymore because they make certain assumptions about a flat class path where you can just do class before name and everything is visible and so on, right? And that requires some massaging of your bundles until you get to a point where this software runs again, right? So there are certain implications of going and buying into a modular world which will, at least initially, manifest themselves into failures, right? So we thought having a log framework inside of Concierge is actually a worthwhile investment, because that way you can correlate your application level log output with low-level systems output, right? It's synchronized, it's correlated, it's a lot easier to make sense out of it. And it just costed us a couple of bytes, so, you know, that is a service that you have as an extra. Other than that, it's just the core and the API that is really required. So let's compare startup time, right? That is the first experience that you will have with an OSGI framework if you're testing out this technology. And you see the startup time across the two BeagleBones VMs and Raspberry Pi. Concierge is consistently the fastest framework to start up, right? We've optimized this path quite a lot, so lower is better, right? And the black bar here is, I would say, the baseline, because that is the time that a Java virtual machine takes until it can print hello world, right? Just the smallest program that you can write. So that is the part that we could not optimize away even if we wanted, right? So we are in the order of just, let's say, 2 times, maybe 3 times the JVM startup. I think that's pretty decent. And again, for comparison, we have a simple bundle that prints hello world. So, you know, you could consider the difference between here and the different frameworks as being the overhead of OSGI on startup, right? So the next thing is the service registry, right? The service registry is the component that you will stress most while your application is running if you buy into this technology. Because you have this loosely coupled system, so you will access it and retrieve services and register services and so on. So we designed the stress test. And the stress test is basically registering 10,000 services that are kind of random generated. Each service has a random value for the same identical key. I already told you you can use filters to find the best matching option. And those filters match against key value pairs that you have associated with your service, right? So we have the same the same key, different values, and the range for the values is just bytes, right? So 256 values possible per key with 10,000 different instances. You get collisions at the order of 39 to 40 identical instances per service registry, just to increase the stress, right? To make sure that the system has to work hard. In the next phase, we will just perform 1,000 lookups. So we will actually retrieve 10% of the services that we have registered. Again, the filters will use byte range. And then ultimately, we have to unregister all these 10,000 services again from the service registry. Now, if we look at the first phase where we register all the services, again, you see that the concierge service registry is consistently the fastest across the different devices. And I would say by quite a margin. Service lookup, this is maybe the operation that happens most frequently at runtime. We have this big outlier here, and this is Felix. I'm not exactly sure why this is the case, because I know the Felix people pretty well, and they tend to tell me how much they optimized on their registry. Well, at least in our experiments, there is still a bit of a gap, I would say. But yes, the performance difference because of these outliers between the other frameworks is not that big. You can still see that Concierge consistently performs the best. And then unregistration, again, we perform very well across the different devices. Another thing to notice, and that's kind of curious, but an experience that we had a lot with embedded devices, performance is not necessarily consistent, right? So you see that for unregistration, the Compact 1 profile is faster than the Java Embedded 7, whereas for service lookups, that's not the case, right? So different JVMs make different trade-offs in terms of, let's say, JIT threshold and how well they support certain bytecodes. And that's why we designed Concierge in a relatively straightforward and no-nonsense way, right? The code is relatively no-nonsense, imperative, not highly object-oriented as you would expect it from a large software project, simply because those things tend to be problematic on embedded devices. No, not all of them might be jitted away at runtime and actually contribute to overhead. So the next thing is the resolver, right? The resolver is what gets stressed most if you install bundles into your system. And in order to test it, we just generated 1,000 random bundles. We can just synthesize them at runtime and then install them. And we had a little setup that, you know, we pick import or export of up to 5 packages, totally 50 packages and so on, right? Generate random import and export ranges, and then install all the bundles. Now it tends to be, it turned out that this benchmark is extremely volatile. And that kind of makes sense, right? Because, you know, being perfectly random with how much you import, how much you export, you know, the end result is that the experiment would have to be repeated a lot of times to produce stable outputs. So what we do for this one is we have just materialized one of those configurations where you have a certain topology of imports and export, right? That's basically a DAG. And we just reuse this across the devices and across the framework. So the absolute values might not be very meaningful because you could randomly generate another topology and it would produce different values. Could be dramatically different values. But it's still comparable because this is just materialized into a big hash and then we reproduce the same topology with the hash. And yes, the first one that we can look at is how much time does it take to install the 10,000 bundles. It again turns out that Felix has a bit of a performance issue here, but Concierge performs consistently the best. I also had a bit of a problem running Equinox on Compact One, and I'm really not quite sure why that is, but we will figure that out. Resolving is one of the areas. I'm pretty much doing these numbers for 1.5 years now. That is an area that all frameworks have improved over the last years, right? So you can see there is not really a lot of difference here, except maybe for Equinox. But the thing with Equinox is the first resolving attempt will have a little bit of overhead, but then it caches very aggressively. So that is basically the value for the first resolving attempt, right? And yes, other than that, the rest of the numbers are pretty much within noise. And then, oh, I know I didn't even provide uninstallation. I think I skipped over that slide, but uninstallation is very similar to what you see for the installation. All right, so hopefully I could convince you that OSGi is a really natural fit for IoT, and Concierge provides you with an optimized and lean framework in order to write IoT applications. If you want to test this technology, just download the native snapshot with all the optimization and REST interface from our homepage where we provide the nightly integration builds, or just clone our code from GitHub. And yeah, let us know what you think, and if you like to use it, we would be curious to hear about it. I will also shamelessly plug some advertisement for our IBM booth where you can visit and participate in interesting games and win prizes. In fact, I was even provided with some t-shirts here that I can give away after the session. So with all that, I would like to thank you for your attention, and I'm happy to take your questions.